So I've taken off the top of the lockbox because this is where all the goodies are. And we're going to take a look at that. This is a little shield here so that when you're using the lockbox you don't bump into any of the electronics. Took the last screw out here, and let's take this shield off. And these are the innards. So over here we have the Arduino, we have the buzzer, we have the display, we have the 3 switches, and we have the power switch, an external power connector, and an internal 9-volt battery with a connector. And of course we have the locking mechanism. Now, I've not permanently attached the locking mechanism to the top of the lockbox because I wanted to show it to you. So let me take it out. I put 2 screws in to hold it temporarily. Let me take those out. And here's the locking mechanism. This is built up so that the actual lock will come out where it's supposed to. But let's take it apart so we can better see what this is all about. And here it is. It's simply a micro servo, and I have a gear, which is a pinion gear, and I have a rack gear which serves as the movement mechanism for the locking bar. Let me take the locking bar out. I can show it to you. Here's the locking bar, and it just has a pinion gear nailed to it on the side. And this goes in. Just like that. There we go. Now, look here. I will enter the combination. And press the lock on lock switch, and this will go back in. As you notice, it did. Now we have one more thing to talk about, and that is these 4 potentiometers which serve as the combination setting devices. In operation, the Arduino goes out and reads the voltage that is present across these 4 potentiometers. One side of the potentiometer is at 5 volts, the other is at ground, and the middle wiper has a voltage that's proportional to its position. The Arduino reads that and then scales it through a small algorithm to a number between 0 and 9. So that's how it knows what the combination is at any time. If the power is removed, it doesn't matter because these potentiometers stay where they are. So let's take a look. We're going to turn the unit back on. And in the interim, I've changed the combination to 1, 2, 3, 4. So let's put that in. And you hear that? The locking mechanism has moved in, so it's unlocked. Now, at this point, we're going to be able to change the combination. So what I'm going to do is I'm just going to randomly move these things around like that. And then I'm going to go over here. I'm going to hold the up button until a new message comes on the screen. And that says set pots for code. And it will show me what the current code is. And in this case, it's 6697. Now, if I move this one here like this, you notice it now says 1697 because I've moved it. So I'm going to move it a little more. I'm going to do it under here so that you can see the changes being made. I'm going to move it to 0, 1, 2, and 3. And when I press the unlock button, the locking mechanism will come out and that new code will be set. Okay, locking mechanism is out. So let's try it. 0, 1, 2, 3. Oh, I went to 4. Just keep going around and it loops back. And here we go. And you notice the locking mechanism went back in. So that's how we reset. Now, if for any reason the battery that's internal loses its power and won't power the Arduino, we can put the switch in this position and attach a 9-volt power source to here, and then the unit will operate. And that's the one reason why this is Pickproof, because you don't need a secondary access lock. In many of these electronic units, what happens is, in case something fails, they always have a secondary access lock, which is usually a very simple lock and it's easy to pick. I learned that from the lock-picking lawyer. In this case, there is no secondary lock. There's just an access point for power, and that makes it Pickproof. I've reattached the top to the bottom of the lockbox, and let's take a little closer look. I made the inside 9 inches by 12 inches so that it would fit standard folders, which I'd like to keep in here. I made it out of wood, but you could make it out of anything you like, plastic, metal, anything you'd like. I also attached the top to the bottom using a piano hinge or a continuous hinge. This hinge, you can't take the center pin out, and it is not accessible from the back, so there's nothing you can do to take it apart and get the top off. Of course, a lockbox is portable, so it's not impervious to destructive entry. That's not what it's about. What you're trying to do is not have anybody have access to it in the normal course of events. So whatever you make it out of, whatever you use to hinge it, should be such that it's safe from casual intervention. Of course, the lockbox does not work unless you have the source code. And this is the source code. It is written using the Arduino IDE, and it is set up for an Arduino Nano. Now, of course, you can enter all this in based on what you see on the screen, but if you'd like to get an actual copy of the source code and some additional information on the build, you can contact me by emailing me at brodafinjr@optimum.net, and I'll be happy to send something out. And of course, as always, if you like this video, please give me a thumbs up, and if you're not a subscriber, I'd appreciate you subscribing. So have some fun and build your own lockbox.